To everyone watching this video right now, take a look down at your feet. Beneath the solid ground, the concrete, the dirt, and the rocks you are standing on. What lies beneath? It is dirt. And below that, more dirt. Go deeper still, and it's rock. And even deeper, strata built up over hundreds of millions of years. The question we are going to explore today might be a bit uncomfortable. What if we are not the first civilization on Earth? If this sounds like a scene from a sci-fi movie, you are half right, but you are also half wrong. This is actually a hypothesis officially published in an academic journal by scientists from a NASA-affiliated institute. The question they posed was this: if an intelligent species existed on Earth tens or hundreds of millions of years ago, could we find their traces? Or rather, there is a more important question before that. Even if we found those traces, would we be able to recognize them as the remnants of a civilization? To answer this, we first need to completely discard our current sense of time. We must accept that what we call ancient times is actually a very short and very recent past. Now please turn on your imagination for a moment. We are about to slowly dive deep into the massive river of time, much, much deeper than the pyramids, Stonehenge, or any human record. And by the end, you might just look at the ground beneath your feet with entirely different eyes. So, let's begin. First, we must face one fact. The Earth is old. The Earth is an eraser. It is much older than we imagine. In school, when we think of ancient civilizations, we usually think of the Egyptian pyramids, Mesopotamian cuneiform, or the Yellow River civilization. At most, that is a story from 5,000 to 10,000 years ago. However, the Earth is about 4.5 billion years old. It is hard to grasp just how massive that number is, isn't it? Let me give you a comparison. Let's compress the Earth's 4.5 billion year history into a 24-hour day. How much of that would be the 10,000 years of human civilization? It would be just 0.2 seconds before midnight. Just 0.2 seconds out of 24 hours. In the blink of an eye, the entirety of human civilization began, developed, and reached its current state. So, what happened on Earth during the 23 hours, 59 minutes, and 59.8 seconds before that 0.2 seconds? For the vast majority of that time, there was no intelligent being like humans on Earth, at least as far as we know. If we can't even do that, our search for aliens might be a sandcastle built on a flawed premise from the very beginning. There is another meaning to this hypothesis. It turns back into a mirror reflecting ourselves. Imagine we are geologists 100 million years in the future. If they dig through the strata of the 21st century and find some traces, would they be able to recognize us? This question teaches us a strange kind of humility. So, let's imagine, what remains after 100 million years? If an intelligent species achieved an industrial civilization similar to ours 100 million years ago, what would be left now? To jump to the conclusion, almost nothing remains. Think about the city you are living in right now. Skyscrapers, asphalt roads, subways, bridges, airports. If all of this were left exactly as it is and humanity suddenly vanished, what would happen? The simulation results from geologists and futurists are shocking. 100 years later, plants will conquer the cities. Roads will crack, and building exteriors will be covered in vines. Windows will break, and rainwater will seep inside. 500 years later, most concrete buildings will collapse. Steel frameworks will rust and corrode. Cities will turn into ruins. 10,000 years later, the traces of artificial structures on the surface will almost entirely disappear. Plant roots will shatter concrete, and microbes will break down the steel. 100,000 years later, if a single ice age passes through, almost all physical evidence of our existence will be ground away. Glaciers will carve out the surface like giant sandpaper. 1 million years later, we will be practically invisible geologically. And what about 100 million years later? We would be erased almost perfectly. It would be hard to even know that anything had happened. Here is an interesting fact. In an interview, Schmidt presented a fascinating calculation. He noted that the dinosaur fossils we discover represent roughly one bone every 10,000 years. Over the 160 million years that dinosaurs ruled the Earth, those massive animals must have lived and died in countless numbers. Yet, the fossils we have found are just a tiny speck in that vast expanse of time. Becoming a fossil requires incredible luck, rapid burial, mineral replacement, and protection from erosion. All these conditions must align perfectly, and even then, they must be luckily exposed and luckily discovered by someone. So what about cities, books, cell phones, fiber optic cables? Or would they conclude that some intelligent being farmed chickens? These subtle chemical fingerprints might be the most enduring traces of humanity. Now, let's think about this in reverse. Past anomalies. If there was a civilization in the past, they might have left similar chemical traces. And we might have already seen those traces. It's just a matter of how we interpreted them. Here is a truly fascinating case. 56 million years ago, something strange suddenly happened on Earth. Geologists call it the PETM event. Translated, it means the Paleocene-Eocene thermal maximum. What happened during this period? Over a very short geological time frame, the Earth's average temperature rapidly spiked by 5 to 8 degrees Celsius. 5 to 8 degrees might not sound like much, right? Not at all. A 5-degree rise in the global average is a catastrophic event. The difference between an ice age and an interglacial period is usually only about 4 to 5 degrees. Atmospheric carbon dioxide levels skyrocketed, the oceans acidified, and oxygen in the deep seas was depleted. Many species went extinct, and new ones emerged. The event lasted for about 200,000 years. But here is a really interesting point. The amount and ratio of carbon released into the atmosphere during this period is astonishingly similar to the carbon emitted by humanity in the 200 years since the Industrial Revolution. Of course, scientists believe the cause of PETM was natural. They presume it was volcanic activity, the release of methane hydrates from the seafloor, or a combination of both. There is also a meteorite impact theory. However, in their paper, Schmidt and Frank ask, if we were geologists 100 million years from now, how would we interpret the changes in carbon isotopes left by human activity in the 21st century? Wouldn't they probably conclude that it was a natural methane release? Doesn't that send a chill down your spine? When we see an event like PETM in the geological record, we just think, nature did it. But what if it wasn't nature's doing? What if it is the trace of a species driving itself to extinction? Could we tell the difference? Let me give you another interesting example. There are strange metal spheres discovered in a region called Klerksdorp in South Africa, specifically in the nearby Ottosdal mine. Their diameter ranges from 0.5 cm to 10 cm. Their surfaces are engraved with strangely parallel grooves. The problem is the age of the rock where these spheres were found. It is roughly 2.8 to 3.1 billion years old. 2.8 billion years ago, there were only single-celled bacteria on Earth. How could such seemingly sophisticated spheres exist? Of course, scientists have a clear conclusion. These spheres are concretions naturally formed from the condensation of pyrite and hematite. Nature can sometimes create astonishing geometric shapes. Similar natural structures include Moki marbles in Utah, USA, and Meraki boulders on beaches in New Zealand. But when these were first discovered, records show that even a museum curator said they looked like artificial objects. This is where Schmidt and Frank's insight shines again. If true artificial artifacts did exist, aren't we perhaps just interpreting them as natural phenomena? There is another mysterious case. The Oklo reactor, nature's nuclear plant. The Oklo mine in the Gabonese Republic in 1972. Francis Perrin, a chemist working at a French nuclear fuel processing plant, was shocked while analyzing uranium ore brought from Gabon. In nature, uranium consists of a mixture of two types, uranium-238 at 99.3% and uranium-235 at 0.72%. This ratio is exactly the same anywhere in the world. It is even the same in meteorites brought from the moon. However, the ratio of uranium-235 in the Gabon ore was 0.717%. It was 0.013% lower than normal. Although it was literally a microscopic difference, physicists were shocked. Initially, they thought someone had stolen the uranium-235 to build a nuclear bomb. Based on the amount mined from Gabon, it was enough material to build 6 nuclear bombs. An investigative team was dispatched to Gabon. But throughout the mine, they found rocks that looked as if they had been scorched black. It was as if someone had torched the place with a flamethrower, Crucially, however, it was confirmed that this mine had remained untouched by anyone for 1.7 billion years. So where did the uranium-235 disappear to? And what burned the rocks? The investigation revealed a shocking fact. About 1.7 billion years ago, a nuclear fission reaction occurred naturally in this mine, and it sustained itself slowly and continuously for hundreds of thousands of years. The average output was about 100 kilowatt, similar to the output of a small human-made nuclear reactor model. The mechanism behind this natural nuclear reactor is as follows. 1.7 billion years ago, the natural concentration of uranium-235 was much higher than it is today. It was about 3%. Groundwater acted as a moderator to slow down the neutrons, and purely by chance, all the conditions aligned perfectly. Nature performed nuclear fission 1.7 billion years ahead of humans. Humans achieved the first artificial nuclear fission in Chicago in 1942, but the Earth was already doing the exact same thing 1.7 billion years ago. If someone had looked at this trace and concluded, "Ah, some ancient civilization generated nuclear power here," what would have happened? It would have been the wrong conclusion. But can we completely rule out that possibility? Geologists frequently encounter unidentified anomalies, instances where a specific stratum suddenly shows abnormally high concentrations of a certain metal, or oxygen isotope ratios exhibit an unexplainable pattern, or chemical compositions display a bizarre distribution. Most are ultimately explained by natural causes: volcanoes, meteorite impacts, climate shifts, microbial activity, and so on. But some still remain a mystery. Science is cautious. It must be cautious. The hypothesis that intelligent life caused an anomaly should be the absolute last one considered, and only examined after all other possibilities have been ruled out. This is not science's weakness, but its strength. However, at the same time, it is also a trap. If such traces truly exist, we are essentially classifying them as natural phenomena forever. Redefining civilization. Now let's dive into a deeper question. What exactly is a civilization? When we say civilization, there are things we usually think of: cities, writing systems, governments, monuments, roads. But this is a very narrow definition. Just looking at human history proves this. There is a 9,000-year-old settlement in Turkey called Çatalhöyük. It is a Neolithic village. It was registered as a UNESCO World Heritage Site in 2012. There are no streets here. There are no plazas. There are no monuments. There is no writing. Houses are tightly packed together, and people entered and exited through the roofs. It looked like a giant honeycomb. The population reached about 8,000. Yet scholars consider this to be one of humanity's first cities. Why? Because there, people cooperated, performed rituals, buried their dead, and farmed. It is not the superficial form, but the pattern of behavior that makes a city a city. So, let's broaden our perspective. What if a species 100 million years ago formed a civilization in a completely different way from us? For example, what if they didn't use metal? Come to think of it, 99% of human history was an era without metal. The Bronze Age started roughly 5,000 years ago. It took 300,000 years after the emergence of the human species for us to make bronze for the first time. Stone Age humans were undoubtedly intelligent beings. They made tools, drew pictures in caves, buried their dead, and developed language. But if they had gone extinct and 100 million years passed, would we be able to know they existed? A few fossils, some well-preserved cave paintings. That would be all the information left. Their songs, their myths, their social structures, their loves. All of it would vanish. Here is one more mind-blowing thought. Look at termites. A termite mound is not just a pile of dirt. It has an internal ventilation system. It maintains a constant temperature and humidity. They farm fungi. The entire colony operates like a single organism. If an alien scientist came and saw the termites, would they call it a civilization? Or would they just classify it as a natural phenomenon? Intelligence can exist in forms far more diverse than we imagine. Look at the octopus. An octopus has 9 brains. Strictly speaking, 1 central brain and 8 small brains, 1 in each arm. They use tools, solve problems, and employ camouflage. Some octopuses even gather coconut shells to build mobile homes. Look at crows. They make tools, remember family members for up to 7 years, and recognize human faces. They are even observed teaching younger crows how to use tools. Look at elephants. They exhibit behavior that looks like mourning by touching the bones of deceased companions. They can also recognize and avoid a human who abused them 60 years ago. If a civilization 100 million years ago thought in a completely different way, cooperated in a completely different way, and altered their environment in a completely different way, how would their traces appear to our eyes? Perhaps we have already seen them, but we are just calling them nature. This question forces upon us a profound humility. We have defined intelligence solely in our own image. We have imagined civilization only in our own shape. But the universe and the deep time of Earth might harbor far more diverse possibilities than we imagine. The Anthropocene. Our chemical epitaph now. Let's turn the mirror back on ourselves. It means an era where humanity has become a primary agent driving geological change. If geologists examine the Earth 1,000,000 years from now, what will they call this era? First, they will discover sudden chemical changes. A rapid increase in atmospheric carbon dioxide, strange synthetic molecules found in soil and on the seafloor, and plastic particles spread globally. They will find strange metal distributions, concentrations of aluminum, copper, and rare earth elements in locations impossible under natural conditions. Refined metals suddenly appearing deep in mountains or on the ocean floor. They will discover a sudden mass extinction. The traces of a human-caused extinction event, often called the sixth mass extinction in Earth's history. Thousands of species disappear every year. This is about 1,000 times faster than the natural extinction rate. They will find strange shifts in isotopes, plutonium and cesium suddenly appearing from 1945, and a shift in the ratio of carbon isotopes starting from the Industrial Revolution around 1750. And they might even find chicken bones. Combining all of this, what will they conclude? Something major happened during this period. It will probably be limited to just that. Whether they could distinguish if it was volcanic activity, a meteorite impact, a natural disaster, or the activity of an intelligent being is unknown. Here, Schmidt points out a strange irony. If a civilization develops in a more sustainable and eco-friendly way, the traces they leave on their planet will be fewer. Then our chances of finding them also decrease. In other words, the longer a civilization survives and thrives, the less likely it is to be discovered by someone in the future. Only the civilizations that most violently ruin their planet will leave definitive traces. This is quite a depressing realization. All of our cities, all of our books, all of our music, all of our love and hate, all of it might eventually be compressed into a single line of chemical data. A layer of plastic, a surge in nuclear age isotopes, a sudden carbon spike, and an explosion of chicken bones. How does it make you feel that this might become the epitaph of human civilization? Conclusion: what will we leave behind? Every time I think about this, I realize one thing. The assumption that we will last forever. The assumption that we will be the last. The assumption that we are the first. All of these are actually very egocentric assumptions. The Earth has embraced countless life forms over 4.5 billion years, and most of them are now gone. We don't know their names, their appearances, or their stories. We are highly likely to end up the same way. Whether that is 100 years, 10,000 years, or 1,000,000 years from now is unknown. But we will not last forever. This is not pessimism. It is an acknowledgement of facts. Now, we are at the end of the video. Have we found an answer? No. The Silurian hypothesis we discussed today does not prove the existence of any lost civilization. It doesn't even claim that one existed. Schmidt and Frank themselves clearly state that the probability of such a civilization existing is very low. But the question it poses is much more fundamental: that the Earth forgets far more than we think, that the river of time is far deeper and more ruthless than we imagine, and that our perception is far narrower than we believe. If we are the first civilization, we are lonely pioneers, the first consciousness in the universe to begin recognizing itself, the first beings to look at the stars and ask for meaning. If we are not the first, we are just a dot in a long flow. We might be walking a path someone else has already walked, and someone else might come after us. Either way, one thing is clear: we are not eternal. To everyone watching this video, think about this for a moment. When some entity digs through the Earth's strata 100 million years from now and finds the traces of the 21st century, what do you want them to find? Plastic, concrete, nuclear waste, fossils of extinct creatures, chicken bones, or some trace of wisdom, some evidence of coexistence, some footprint of responsibility. The chemical fingerprints we carve into the Earth become our epitaph. How we live in this very moment determines how someone 100 million years from now will remember us. And perhaps, if someone truly did exist before us, they might have asked the same question in their final moments. What are we leaving behind? The Earth does not answer. The Earth simply accepts, buries, and piles new time on top of it. Our story today didn't provide an answer, but perhaps it left you with a good question. The next time you look at the ground beneath your feet, please pause for a moment and think. How many stories does this land hold? What has this land forgotten? And what will we leave on this land? That is all for today's story. I'll be back next time with another deep question.